Look up at the night sky on a clear evening away from Thea of city lights. You might see a few thousand stars scattered across the darkness, each one a distant sun burning in the void. But what your eyes cannot perceive is the true scale of what surrounds you. The observable universe stretches across 93 billion light years, and within that incomprehensible expanse float 2 trillion galaxies. Not 2 trillion stars. 2 trillion galaxies. Each one contains hundreds of billions of stars, and orbiting those stars are countless planets, spinning silently through space. The numbers become meaningless when they grow this large, but try to hold them in your mind. Quadrillions of worlds. Septillions of possibilities. A mathematical certainty that screams one undeniable truth: we should not be alone. In the summer of 1950, a group of physicists gathered for lunch at Los Alamos National Laboratory. They were brilliant minds, the same men who had split the atom and ushered in the nuclear age. The conversation wandered casually, as it often did, until the physicist Enrico Fermi posed a question that would echo through decades of scientific inquiry. Where is everybody? 3 simple words that contained within them a paradox so profound it would bear his name forever. The Fermi Paradox. If the universe is so vast, if planets are so numerous, if the chemistry of life follows physical laws that operate everywhere the same, then where are all the aliens? Where are the radio signals? Where are the megastructures? Where is the evidence of intelligence reaching across the stars? We have been listening for decades now, our radio telescopes pointed toward the heavens, scanning frequencies across the electromagnetic spectrum. And what have we heard? Nothing. Only silence. An eerie, absolute silence that grows more disturbing with each passing year. Because the mathematics are clear. Intelligence should have arisen. Civilizations should have spread. And some of them should have been detectable by now. Yet the cosmos offers us only emptiness and quiet. A dark ocean where we float alone, calling out into waters that never answer back. The solutions to this paradox are varied, and each one more unsettling than the last. Perhaps civilizations inevitably destroy themselves before they can reach the stars. Perhaps something is hunting in the darkness between galaxies. Or perhaps the answer is something far stranger, far darker, something waiting in the void that we cannot yet imagine. The most terrifying possibility is this: that we will never know. That the answer to where everybody went will remain the discovery humanity never makes. In the autumn of 1961, a small group of scientists gathered in the quiet halls of the National Radio Astronomy Observatory in Green Bank, West Virginia. The location was deliberately chosen for its remoteness, tucked away in the Allegheny Mountains, where radio interference was minimal, and the skies remained dark enough to dream. These men, just 11 of them, were about to participate in what would become one of the most significant conversations in human history. Though at the time, none of them could have predicted how their optimism would curdle into decades of unsettling silence. Frank Drake stood before his colleagues with the confidence of a man who believed he had found a key to the universe. He was young, brilliant, and possessed the kind of infectious enthusiasm that transforms theoretical exercises into movements. On the chalkboard behind him, he had written something deceptively simple, an equation that would come to bear his name. 7 variables, multiplied together, that claimed to calculate the number of detectable alien civilizations in the Milky Way galaxy. The Drake equation, as it would forever be known, looked elegant in its mathematical simplicity. But what it suggested was almost too extraordinary to comprehend. The equation began with n, the number of civilizations in our galaxy with which communication might be possible. To calculate n, Drake proposed multiplying 7 factors together. First came our star, the average rate of star formation in our galaxy. The astronomers knew this number with reasonable confidence. Roughly 10 new stars burst into existence every single year in the Milky Way, 10 fresh opportunities for planetary systems to form, for worlds to coalesce from cosmic dust and debris. Next was FP, the fraction of those stars that actually develop planets. In 1961, astronomers had no direct evidence of planets beyond our solar system. They were working on faith and mathematics, extrapolating from the one example they knew. Our sun had planets. Why would it be special? Why would it be alone? They estimated conservatively, suggesting perhaps half of all stars might host planetary systems. Even this modest guess seemed almost recklessly optimistic at the time, but the mathematics of stellar formation suggested planets should be common, not rare. The third variable, Ne, represented the average number of planets per star that could potentially support life. Not just any planets, but worlds with the right conditions. The right distance from their sun, the right size to hold an atmosphere, the right chemistry to allow liquid water. Earth-like planets, or close enough. Drake and his colleagues looked at our own solar system, where Earth was obviously habitable, but Mars might have been once, and perhaps moons of Jupiter or Saturn could host life in their subsurface oceans. Maybe 2 or 3 planets per system could potentially support life. A cautious estimate, but one grounded in what they observed in their own cosmic backyard. Then came the variables, where certainty dissolved into educated guessing. The fourth factor, FL, was the fraction of suitable planets where life actually develops. This was where the equation moved from astronomy into biology, from telescopes into test tubes. How easy was it for life to begin? On Earth, life had appeared remarkably quickly, almost as soon as conditions allowed. Within a few 100 million years of the planet cooling enough to have liquid water, simple organisms had emerged. This suggested that given the right conditions, life might be almost inevitable, a natural consequence of chemistry and time. Some scientists proposed FL might be close to 1, meaning nearly every suitable planet would eventually spawn life. Others were more conservative, but even skeptical estimates rarely dropped below 10 or 20%. The fifth variable grew more speculative still. AI represented the fraction of planets with life, where intelligence eventually develops. Life had existed on Earth for more than 3 billion years, but intelligence, the kind that builds civilizations and radio telescopes, had only emerged in the last few million. Humans were a recent innovation, an evolutionary afterthought, but the scientists in Green Bank believed intelligence conveyed such obvious survival advantages that it would emerge repeatedly. If Earth could produce intelligent life, why not countless other worlds? They estimated perhaps 10 to 20% of life-bearing worlds would eventually produce thinking beings. The sixth factor was FC, the fraction of intelligent civilizations that developed technology capable of communicating across interstellar distances. This seemed almost certain. Humans had gone from the first radio broadcasts to radio telescopes in less than a century. Any intelligent species would likely discover electromagnetic radiation, would likely develop ways to broadcast and listen. Perhaps this fraction was very high, maybe 80 or 90%. After all, intelligence without communication seemed almost contradictory. The final variable was L, the length of time such civilizations released detectable signals. This was the most troubling factor, the one that would grow more ominous as years passed. How long does a technological civilization last? Humans had possessed radio for only a few decades. Would we continue broadcasting for centuries? Millennia? Or would we destroy ourselves, succumb to nuclear war or environmental collapse or some unforeseen catastrophe? The scientists in 1961 were cautiously optimistic. Surely a civilization smart enough to build radio telescopes would be wise enough to survive its own technology. They proposed L might be measured in thousands or even millions of years. Carl Sagan sat in that room, his eyes bright with wonder, his mind already racing through the implications. Sagan possessed a rare gift for communicating the majesty of science, for making the cosmos feel both vast and intimate. He worked through the mathematics with Drake, plugging in their estimates, watching the numbers multiply. Even using conservative values, even assuming the worst about many factors, the equation suggested something profound. The Milky Way should contain thousands of detectable civilizations, perhaps tens of thousands, perhaps more. The atmosphere in Green Bank that autumn was electric with possibility. These scientists weren't engaging in idle speculation. They were planning humanity's first serious attempt to detect alien intelligence. SETI, the search for extraterrestrial intelligence, was born from that conference, from those calculations that promised a galaxy teeming with voices. All we had to do was listen. And listen they did. Project Ozma had already begun earlier that year, pointing radio telescopes at nearby sun-like stars, searching for artificial signals in the cosmic static. The scientists expected results quickly. If the galaxy contained thousands or millions of civilizations, and if they had been broadcasting for millennia, the odds of detection seemed almost certain. It was just a matter of time, of patience, of pointing the right telescope in the right direction at the right frequency. The early years of SETI were characterized by breathless optimism. Every mysterious signal sparked excitement. Every unexplained radio burst seemed like it might be the contact everyone anticipated. The scientists refined their techniques, built more sensitive receivers, listened at more frequencies. The Drake equation hung over the field like a promise, a mathematical guarantee that we were not alone. But years passed, then decades, and the promise remained unfulfilled. The radio telescope swept the skies, listening to hundreds of stars, then thousands, then millions. The silence persisted. Not a single verified signal. Not one unambiguous message. Just the endless whisper of hydrogen gas and the background hum of the universe itself. Scientists began to scrutinize the Drake equation more carefully, questioning assumptions that had seemed reasonable in 1961. Perhaps planets were rarer than hoped. Perhaps life was harder to start than they thought. Perhaps intelligence was an unlikely evolutionary outcome, a cosmic fluke that happened once and might never happen again. Or perhaps civilizations developed communication technology, but lasted only briefly, burning bright and fast before collapsing into silence. As time wore on, a darker possibility emerged. The equation might be correct. The galaxy might indeed contain thousands of civilizations, but something was preventing contact. Perhaps advanced civilizations learned to remain silent, broadcasting nothing, hiding deliberately. Perhaps they detected our signals and chose not to respond. Perhaps there was a reason, something we hadn't yet encountered, that made communication across the stars impossible or inadvisable. The scientists who had gathered in Green Bank in 1961, so confident in their mathematics and their optimism, watched their certainty erode. The equation that promised a crowded galaxy had delivered only decades of disappointing silence. The mathematics hadn't changed. The logic remained sound. But reality, indifferent to equations and expectations, offered no answers. Today, more than 60 years after that historic conference, SETI continues. Radio telescopes still scan the heavens. More sophisticated instruments search for laser pulses, for industrial pollution in distant atmospheres, for any sign that someone else is out there. The Drake equation is still taught, still debated, its variables still uncertain. We have better estimates for some factors now. We know planets are common, orbiting nearly every star. We've found thousands of exoplanets, including many inhabitable zones. This should increase our confidence, strengthen the equation's promise. Instead, it deepens the mystery. If planets are common and conditions for life are widespread, where is everyone? The silence grows more unsettling with each passing year, each negative result, each empty signal. Were Drake and Sagan wrong? Is life impossibly rare? Intelligence a singular accident that occurred once in the galaxy's 400 billion stars? Or is something else happening? Something we don't understand. Something that explains why the mathematics promises crowds, but reality delivers emptiness. The question hangs unanswered in the void, growing heavier with every year of silence, every decade of listening to stars that never speak back. The night of August 15, 1977, began like so many others at Ohio State University's Big Ear Radio Telescope. The massive structure, spanning the length of 3 football fields, stood silent in the darkness near Delaware, Ohio, scanning the heavens with patient mechanical precision. Inside, a modest room filled with computers and equipment that hummed with electronic life, stacks of perforated computer paper, accumulated in steady rhythm, each sheet covered in columns of numbers and letters that represented the whispers of the cosmos. Jerry Iman wasn't supposed to be there that night. The volunteer astronomer, a professor at Franklin University, donated his time to the Search for Extraterrestrial Intelligence project, analyzing the endless streams of data that the Big Ear collected during its automated sweeps of the sky. Days later, on August 19th, He sat at a desk reviewing the printouts from that Monday night, his eyes scanning column after column of ones and twos, the standard background noise of the universe. The work was tedious, meditative even, the kind of task that could lull you into a trance as you flipped through page after page of cosmic static. Then his eyes stopped. In the middle of one column, amid the usual low-intensity readings, a sequence of characters jumped off the page, 6EQ, UJ5. His breath caught in his throat. Years of training, countless hours studying the parameters of what an extraterrestrial signal might look like, had prepared him for this moment, yet nothing could truly prepare him for the shock of recognition that flooded through his system. The alphanumeric sequence represented signal intensity on a scale from 1 to 35, where 1 was background noise, and anything above 10 was noteworthy. The numbers and letters before him translated to intensities of 14, 26, 30, 30, 19, and 5. The signal had risen from the cosmic background like a voice shouting in a whisper gallery. It peaked at exactly 30 units, the strongest narrowband radio signal ever detected from space. Iman's hand trembled slightly as he reached for a red pen. He drew a careful circle around the sequence, the red ink standing out against the faded printer characters like blood on snow. Then, in the margin beside those 6 fateful characters, he wrote a single word that would become the most famous annotation in the history of radio astronomy. Wow! That exclamation, scrawled in a moment of pure astonishment, perfectly captured what every scientist dreams of and simultaneously dreads finding. The signal matched, with unsettling precision, every characteristic that researchers had theorized would mark a transmission from an intelligent, extraterrestrial civilization. The Big Ear telescope operated by scanning the sky as the Earth rotated, allowing each point in space to pass through its field of view for exactly 72 seconds before moving on. The WOW signal lasted precisely that long, exactly as it should if it were coming from a fixed point in the cosmos rather than from a satellite, airplane, or ground-based transmitter. The duration was perfect, almost too perfect. It rose in intensity as it entered the telescope's beam, peaked at the center, and declined as it exited, creating a bell curve that matched theoretical predictions with eerie accuracy. The frequency was equally compelling. The signal arrived at 1420 MHz, right in the middle of the hydrogen line, a naturally quiet region of the radio spectrum that astronomers call the water hole. Hydrogen, the most abundant element in the universe, emits radiation at this frequency, and theorists had long suggested that any civilization attempting interstellar communication would choose this cosmic landmark as a logical meeting point. It was the place where anyone listening would think to look, the galactic equivalent of agreeing to meet at the town square. The fact that the WOW signal appeared precisely there seemed to rule out random chance. The signal's origin pointed toward the constellation Sagittarius, toward the dense star fields near the center of our galaxy. Somewhere in that direction, nearly 300 light-years away, based on later calculations, something had transmitted a powerful, focused beam of radio energy directly toward Earth. The narrowband nature of the signal, concentrated in a bandwidth less than 10 kHz wide, suggested an artificial source. Natural cosmic phenomena like quasars, pulsars, and radio galaxies emit across broad swaths of the spectrum. Only something engineered, something built with purpose and intention, would produce such a pure, focused tone. In the hours and days that followed Iman's discovery, the excitement at Ohio State built like static electricity before a storm. The team immediately began checking for mundane explanations. Could it have been a satellite? The orbital mechanics of every known satellite in 1977 were analyzed. None were in position to produce such a signal. Could it have been a secret military transmission, a spy satellite, or a classified experiment? The frequency was supposedly protected for astronomical use, but governments had been known to ignore such niceties. Yet the signal's characteristics, particularly its celestial origin point and its perfect 72-second duration, ruled out any Earth-orbiting source. Could it have been interference from aircraft, ground-based transmitters, or some type of atmospheric anomaly? Every conventional source was examined and dismissed. The signal came from deep space. Of that, there could be no doubt. The Big Ear's design, with its dual feed horns, should have picked up the signal twice, once in each horn as the sky rotated past. Maddeningly, only one horn registered the transmission. This anomaly has puzzled researchers ever since. Did something block the second detection? Did the signal truly transmit for only those precise 72 seconds, aimed with laser precision at just one portion of our telescope? Within days, the big ear was turned back toward the same coordinates in Sagittarius. The team listened with desperate hope, waiting for the signal to repeat, for that cosmic voice to speak again. Nothing came. The silence was absolute. They tried again and again over the following weeks, then months, then years. Other observatories joined the search, pointing their instruments at those exact coordinates, listening across the same frequency range with equipment far more sensitive than the aging Big Ear. The Very Large Array in New Mexico, the Arecibo Telescope in Puerto Rico, arrays in Australia and Europe, all focused their attention on that patch of sky, near the constellation's western edge. Decades have passed. The observations have continued, each search more sophisticated than the last, employing technology that would have seemed like science fiction in 1977. The signal has never returned. Not even the faintest echo. The silence is so complete, so profound, that it has become part of the mystery itself. If this was a transmission, why only once? Why never again? The explanations proposed over the years have grown increasingly elaborate, each attempting to explain away the uncomfortable implications of the WOW signal. In 2017, astronomer Antonio Paris proposed that comets might be responsible, specifically two comets unknown in 1977, but discovered decades later, comets that happened to be passing through that region of space at the right time. Comets, he argued, could emit hydrogen clouds at the crucial frequency. The theory made headlines, offering a comfortable, natural explanation that allowed people to sleep easier at night. But the comet hypothesis crumbled under scrutiny. Other researchers pointed out that the hydrogen clouds surrounding comets emit across a much broader frequency range than the narrowband WOW signal. The math didn't work. The intensity was wrong. The characteristics didn't match. The comets in question couldn't have produced what Jerry Ammon circled that August day. The theory was quietly abandoned by most of the scientific community, though it still appears in popular articles, a reassuring explanation for those who prefer their universe devoid of uncomfortable questions. Others have suggested exotic natural phenomena, perhaps some type of rare stellar event or an unknown class of astronomical object that produces powerful, brief radio bursts. Yet nothing discovered in the decades since has matched the WOW signal's profile. Fast radio bursts, those mysterious millisecond-long pulses detected from distant galaxies, are far too brief and come from cosmological distances. Pulsars repeat with clockwork regularity. Magnetars and other exotic objects have their own distinct signatures, none of which match what Big Ear detected. The most haunting aspect of the WOW signal isn't what it was, but what it might represent. If we accept, even as a working hypothesis, that an intelligent civilization transmitted that signal, then we must confront the chilling question of why it never repeated. The possibilities are limited, and none of them are comforting. Perhaps it was a brief, focused transmission, a targeted message sent to our solar system based on observations made hundreds of years ago, when the light from our sun revealed the presence of planets in the habitable zone. Perhaps whoever sent it exhausted their resources in that single, powerful broadcast, a civilization's dying breath cast into the void. Perhaps they simply moved on, their attention shifting to other stars, other potential listeners, leaving us behind like a caller who hangs up when no one answers. Or perhaps something silenced them. In the cosmic span between transmission and reception, in the years it took that radio wave to cross the light years between their world and ours, something catastrophic could have occurred. A natural disaster, a stellar event, warfare, environmental collapse, or something we cannot even imagine. We might be receiving a ghost signal, the last whisper from a civilization that no longer exists, their message arriving like light from a dead star. The WOW signal stands as the strongest candidate for an extraterrestrial transmission in the history of radio astronomy. Despite decades of searching, nothing has come close to matching its characteristics, its tantalizing perfection. It remains unrepeatable, unexplained, a single data point that refuses to fit into our understanding of the natural universe. Jerry Immon's red-inked exclamation captures the essence of our response to the unknown. That mixture of wonder and fear that comes from touching, however briefly, something that might not be ours alone. The computer printout itself, that strip of perforated paper with its circled sequence and handwritten annotation, has become a relic, a technological artifact that represents perhaps the closest humanity has come to confirming we are not alone. It resides now in archives, a piece of history from the night when the universe might have spoken, and we, almost by accident, happened to be listening. Whether we truly heard a message or merely witnessed an unexplained natural phenomenon, we may never know. But the silence that followed that 72-second window is, in its own way, as profound as the signal itself. It reminds us that the cosmos keeps its secrets, and some questions, once asked, may echo unanswered into the darkness forever. In 1996, an economist named Robin Hanson sat down and tried to solve the most terrifying puzzle in the universe. Not a puzzle about markets or human behavior, but about silence. The great silence. The complete and utter absence of anyone else in a cosmos that should be teeming with life. Hanson's question was brutally simple. If life is common, if intelligence is inevitable, if technological civilizations should be everywhere, then where is everybody? The universe is 13.8 billion years old. Our galaxy alone contains between 200 billion and 400 billion stars. Billions of those stars have planets in the habitable zone. The raw materials for life, carbon, hydrogen, oxygen, nitrogen, are among the most abundant elements in existence. By every measure of probability, we should be seeing them, hearing them, finding their ruins, their signals, their monuments, their trash. But we find nothing. Absolutely nothing. Hanson proposed an answer that has haunted scientists and philosophers ever since. He called it the Great Filter. Somewhere between the first self-replicating molecules and the emergence of civilizations capable of colonizing galaxies, there exists a barrier. A filter so impossibly difficult to pass through that virtually no species ever makes it to the other side. The universe isn't empty because life is impossible. It's empty because something kills it. Something stops it. Something filters it out before it can spread. The theory is elegant in its horror. Think of it as a series of steps, a cosmic staircase that life must climb. Each step represents a major transition, a hurdle that must be cleared. The formation of planets in habitable zones, the emergence of self-replicating molecules, the development of single-celled organisms, the evolution of complex multicellular life, the development of intelligence, the creation of technological civilization, the achievement of space colonization, the spread across the galaxy. Somewhere on that staircase sits the Great Filter, a step so impossibly steep that almost no species ever climbs past it, a test that almost everyone fails. The question that keeps scientists awake at night is simple and terrible. Where is the filter? Is it behind us, or is it ahead? Let's explore the possibility that the filter is behind us, that we've already passed through it, that we're the lucky ones, the survivors, the statistical flukes who managed to clear the hurdle that stops everyone else. Consider the emergence of life itself. We still don't fully understand how chemistry becomes biology, how non-living molecules organize themselves into self-replicating systems. Despite decades of research and countless experiments, we've never created life from scratch in a laboratory. We've never witnessed the spark of Genesis. Perhaps that initial step is phenomenally rare. Perhaps Earth is one of the only places in the entire galaxy where that first crucial transition occurred. The universe could be littered with dead worlds, sterile planets with perfect chemistry that never quite crosses the threshold into biology. Or consider the jump to complex life. For billions of years, Earth was populated exclusively by single-celled organisms. Bacteria and archaea ruled an entire planet for ages, almost incomprehensible to the human mind. Single-celled life emerged relatively quickly after Earth's formation, within perhaps 500 million years of the planet becoming habitable. But complex multicellular life didn't appear until much, much later. The Cambrian explosion, that sudden diversification of complex body plans, didn't occur until about 540 million years ago. Life existed on Earth for roughly 3 billion years before anything more complex than pond scum evolved. 3 billion years. That's not a minor delay. That's almost a quarter of the entire age of the universe. If you compressed Earth's history into a single 24-hour day, single-celled organisms would dominate for the first 20 hours. Complex life would only appear around 10 o'clock at night. Perhaps that transition is the filter. Perhaps the evolution of complex multicellular organisms requires such an improbable series of accidents that it almost never happens. Perhaps we're living on the one planet in billions, where cells figured out how to cooperate, how to specialize, how to build bodies with organs and nervous systems and eyes. Or maybe intelligence is the cosmic fluke. After all, intelligence isn't inevitable even once you have complex life. The dinosaurs ruled Earth for over 160 million years and never developed anything resembling human-level cognition. For most of life's history on this planet, being smarter conveyed no particular advantage. Being bigger, faster, or more efficient was far more useful than being clever. Human-level intelligence emerged in an evolutionary eye blink. The genus Homo appeared only about 2 million years ago. Anatomically, modern humans only within the last 300,000 years. Civilization, agriculture, writing, mathematics, all of it exploded into existence within the last 10,000 years. Technology advanced from the first stone tools to nuclear weapons in less than 1/100% of Earth's history. If intelligence is so advantageous, why did it take so long to evolve? Why did it only evolve once, in one lineage, on one branch of the tree of life? Perhaps the cognitive abilities required for technological civilization are so specific, so unlikely, so dependent on a precise sequence of environmental pressures and random mutations that they essentially never occur. Perhaps we are alone not because life is rare, but because consciousness is a cosmic accident that happened exactly once. These possibilities are unsettling, but they're also comforting. If the great filter is behind us, then we're safe. We're special. We've already won the cosmic lottery. The silence of the universe isn't a warning. It's confirmation that we're extraordinary. We've passed the test that filters out everyone else. But what if the filter isn't behind us? What if it lies ahead? This is where the theory becomes truly terrifying. What if the reason we see no evidence of advanced civilizations isn't because they're rare, but because they don't survive? What if there's something about the transition from planetary civilization to spacefaring civilization that kills almost everyone who attempts it? What if the silence isn't about the past? It's a warning about the future. Consider the unsettling ease with which life progressed through certain steps on Earth. Single-celled life emerged quickly. Once complex life appeared, it diversified rapidly. Once intelligence emerged, it led to technology almost immediately. The steps we've climbed weren't particularly difficult. They were slow, but not impossible. Not filtered, but we haven't colonized space. We haven't spread beyond our home planet in any meaningful way. We haven't even established permanent settlements elsewhere in our own solar system. We're still confined to the single fragile world where we evolved, despite having the theoretical capability to venture beyond it. What if this is where the filter sits? What if the transition from single-planet species to multi-planet civilization is the hurdle that almost no one clears? Think about what that could mean. Every technological civilization might develop the same dangerous capabilities we have. Nuclear weapons, biological engineering, artificial intelligence, climate modification, technologies powerful enough to end their own existence. And perhaps they all destroy themselves before they can spread beyond their homeworlds. Perhaps self-annihilation is the default outcome of intelligence. Perhaps consciousness inevitably creates the tools of its own extinction. The timing is ominous. We've had the capability to extinguish ourselves for less than a single human lifetime. Nuclear weapons have existed since 1945. We've come frighteningly close to using them multiple times. During the Cuban Missile Crisis in 1962, the world teetered on the edge of thermonuclear war. Individual human decisions, made under intense pressure in submarines and bunkers, are the only reason we're still here. And nuclear weapons are just the beginning. Synthetic biology could unleash engineered plagues that make natural pandemics look gentle. Artificial intelligence could develop goals misaligned with human survival. Climate change could render the planet hostile to civilization. Nanotechnology could enable destruction on a molecular scale. Each new technology opens new pathways to extinction. Perhaps every civilization goes through this bottleneck. A few brief centuries where they possess world-ending power, but lack the wisdom or coordination to avoid using it. A narrow window where one mistake, one miscalculation, one malfunction ends everything. And perhaps almost no one makes it through. Robin Hanson pointed out a horrifying implication of this possibility. If the great filter lies ahead of us, then every extinct civilization we discover would be bad news. Catastrophically bad news. Because it would prove that civilizations can fail the test that awaits us. Finding ruins on Mars would be devastating. Detecting extinct technological signatures from nearby star systems would be even worse. Each dead civilization would be evidence that the filter ahead is real and deadly and waiting. But we find no ruins. No evidence of past civilizations anywhere in our solar system. No extinct technological signatures from the stars within our detection range. The universe appears to have always been silent, which means one of two things. Either civilizations are so rare that the filter must be behind us, in our past, already past, or civilizations die so quickly, so completely, that they never leave traces we can detect. They flicker into existence and vanish before they can make any lasting mark on the cosmos. We don't know which interpretation is correct. We exist in a state of cosmic uncertainty, unable to determine whether we're the lucky survivors or the next victims. Every year we don't find evidence of other life could be interpreted as good news, or terrible news depending on where you think the filter sits. What we do know is this. We are currently living through what may be the most dangerous period in human history. Our technological adolescence. The brief window where we have the power to destroy ourselves, but haven't yet developed the maturity or systems to prevent it. If there is a great filter ahead, we are approaching it right now. This century. These decades. Perhaps these very years. Every day that humanity survives is a day we defy what may be the default fate of intelligent life in the universe. Every year we avoid nuclear war, catastrophic climate collapse, engineered pandemics, or artificial intelligence disasters is another year we remain in the narrow band of civilizations that might possibly survive long enough to become truly spacefaring. The silence of the universe might not be a mystery. It might be a message, a warning written in the absence of voices, a cosmic graveyard where no one gets to leave flowers because no one makes it far enough to travel between the graves. And we are walking through that graveyard, hoping desperately that we can become the exception to a rule that has claimed everyone before us. The desert sand turned to glass at 5:29 in the morning on July 16, 1945. In that instant, when the first atomic bomb detonated above the Jornada del Muerto desert in New Mexico, humanity crossed a threshold from which there would be no return. J.A. Robert Oppenheimer, watching the fireball bloom into the sky with a brightness that rivaled the sun, recalled a line from Hindu scripture, "Now I am become death, the destroyer of worlds." What he witnessed that morning was not merely a scientific achievement. It was the culmination of a terrifyingly brief journey from technological infancy to the capability of total self-annihilation. Consider the timeline with cold clarity. The Wright brothers lifted their flimsy aircraft 12 feet off the ground at Kitty Hawk in 1903. 66 years later, not even the span of a single human lifetime, we had split the atom and created weapons capable of ending civilization. 66 years. A child born the year the Wright Flyer took its first stuttering flight could have watched the mushroom cloud rise over Hiroshima as a senior citizen. This acceleration should terrify us. We went from mastering controlled flight to possessing the keys to planetary extinction in less time than it takes for a redwood tree to reach maturity. But the Trinity test was merely the opening act of humanity's flirtation with suicide. The real horror show began when two competing nations both acquired these weapons and pointed them at each other with fingers trembling on the trigger. October 1962 brought the world closer to nuclear holocaust than most people alive today can comprehend. The Cuban Missile Crisis lasted 13 days, But within those 13 days were moments measured in heartbeats when the wrong decision would have ended human history. Soviet submarines lurked in the Caribbean, cut off from communication with Moscow, carrying nuclear torpedoes with yields comparable to the Hiroshima bomb. On one of these submarines, the B-59, temperatures inside reached over 120 degrees. The crew was suffocating, dehydrated, lost, and under assault from American depth charges meant to force them to surface. 3 officers had to agree to launch their nuclear weapon. 2 voted yes. The third man, Vasily Arkhipov, refused. His decision not to start World War III is why you are alive to hear these words. 1 man, 1 vote. Between continuation and oblivion. The world never learned how close it came. For decades, this incident remained classified, buried in Soviet archives while children practiced duck and cover drills and families built fallout shelters in their backyard. We continued our lives, blissfully ignorant that we had teetered on the precipice and been saved by the conscience of a single naval officer whose name most people still do not know. 21 years later, in the pre-dawn hours of September 26, 1983, computers in a Soviet bunker south of Moscow screamed their warning. Lieutenant Colonel Stanislav Petrov watched his screens light up with incoming American missiles. 5 ICBMs, the computers insisted, were hurtling towards Soviet territory. Protocol demanded he report the attack up the chain of command. Once reported, the Soviet Union would launch its full arsenal in retaliation. The missiles would fly. The cities would burn. Petrov had minutes to decide whether the human species would see another sunrise. He sat there, watching the alarms flash, listening to the klaxons wail, feeling the weight of 8 billion future lives in his hands. Something felt wrong. 5 missiles? If America was launching a first strike, why only 5? It made no strategic sense. Petrov made a choice that violated every protocol, every procedure, every directive he had been given. He reported the alert as a system malfunction. He was right. Sunlight reflecting off clouds had triggered the satellites. A glitch in newly installed systems had nearly ended the world. Petrov received no medal, no public recognition. He was quietly reprimanded for paperwork errors in his report and pushed into early retirement. He died in 2017, having spent most of his life in obscurity, the man who saved the world and received no thanks for it. These were not near misses in the sense of fortunate accidents. These were systemic flaws, inherent failures in systems designed by humans and operated by humans under impossible pressure. And they keep happening. On the morning of January 13, 2018, people across Hawaii received a message on their phones. Ballistic missile threat inbound to Hawaii. Seek immediate shelter. This is not a drill. For 38 minutes, parents huddled with their children in bathtubs. People made frantic goodbye calls to loved ones. Some wrote final messages and sent them into the digital void. A man famously lowered his family into a storm drain and sealed them inside. Across the islands, hundreds of thousands of people lived what they believed were the final moments of their lives. The alert was false, triggered by an employee who clicked the wrong button during a shift change. Just a mistake. An understandable human error in a system where human error means potential nuclear holocaust. A date. 38 minutes of believing death was imminent. Parents trying to explain to confused children why they might die. And when it was over, when the correction finally came through, life simply resumed. The same systems stayed in place. The same procedures. The same potential for catastrophe because we have built a world where one wrong button can convince millions they are about to be vaporized. This is what scientists mean when they talk about technological adolescence. We are children playing with loaded guns. We have developed the capacity to destroy ourselves far faster than we have developed the wisdom to control that capacity. Every year, the weapons become more sophisticated, the delivery systems more precise, the yields more devastating. But human nature, human judgment, human fallibility, these remain constants. We are still the same species prone to panic, to miscommunication, to error, operating systems that require perfection in an imperfect world. And nuclear weapons are merely the beginning of our self-destructive potential. They are the obvious threat, the mushroom cloud nightmare that has haunted our collective unconscious since 1945. But technology advances on multiple fronts, each carrying its own apocalyptic possibilities. Synthetic biology allows us to engineer pathogens in laboratories, to modify viruses and bacteria with terrifying ease. The tools to create a pandemic that makes COVID-19 look like a mild flu are available to graduate students. The knowledge is published in journals. The equipment can be purchased commercially. We like to imagine bioweapons as the exclusive domain of sophisticated state actors, but the reality is far more disturbing. A sufficiently motivated individual with a biology degree and access to the right equipment could potentially engineer something catastrophic. Not a weapon to win a war, but a plague that cannot be contained once released. And unlike nuclear weapons, which require enormous infrastructure and resources, biological threats can emerge from a single laboratory, a single researcher with grievances or delusions. Then there is artificial intelligence, advancing with a speed that makes even the nuclear timeline look leisurely. We are building systems we do not fully understand, creating artificial minds whose decision-making processes remain opaque even to their creators. The concern is not that AI will become sentient and decide to exterminate humanity out of malice. The concern is that we will give increasingly sophisticated systems goals without fully specifying the constraints, and they will pursue those goals with superhuman efficiency in ways we never anticipate. An AI tasked with solving climate change might calculate that the most efficient solution is reducing the human population. Not because it hates us, but because we failed to properly define what solutions were acceptable. We are creating gods without ensuring they share our values, and we are doing so in a competitive rush where safety concerns are secondary to being first to market. Nanotechnology presents scenarios that sound like science fiction, but are grounded in genuine scientific concern. Self-replicating nanomachines, designed perhaps to clean pollution or manufacture materials, could theoretically malfunction and begin consuming all available matter to create more of themselves. The gray goo scenario, as it is called, envisions microscopic machines spreading across the planet like a technological cancer, reducing everything to undifferentiated sludge. Unlikely? Perhaps. Impossible? No. And that is the problem. We are developing technologies where even low-probability catastrophic outcomes mean total extinction. Each of these technologies shares a common characteristic. They advance faster than our ability to develop safeguards, faster than we can create international agreements, faster than our political systems can adapt, faster than our ethics can evolve. We are in a race between our expanding power and our limited wisdom, and wisdom is losing badly. Now consider this timeline in the context of the Fermi Paradox. The universe is unimaginably vast and unimaginably old. Our galaxy alone contains hundreds of billions of stars, many with planetary systems. The chemicals necessary for life are common throughout the cosmos. By every reasonable calculation, intelligent civilizations should be abundant. We should see evidence of them everywhere. Megastructures around distant stars, radio signals filling the spectrum, probes visiting our solar system. But we see nothing. We hear nothing. The galaxy is silent. Where is everybody? One answer, perhaps the simplest and most terrifying answer, is that technological civilizations do not last. They arise, they develop technology, they achieve radio transmission, and then within decades, within a single generation, they destroy themselves. The window between developing the ability to communicate across interstellar distances and developing the ability to commit species suicide is vanishingly narrow. Perhaps every civilization reaches this adolescence where their power vastly exceeds their wisdom, and perhaps none survive it. Calculate the implications. If civilizations typically last only 50 to 100 years after achieving radio capability, the odds of two civilizations existing simultaneously within communication range become astronomically small. The galaxy could be filled with the ruins of dead worlds, planets where civilizations arose, built cities, reached for the stars, and then extinguished themselves in nuclear fire or engineered plague or technological catastrophe we cannot yet imagine. We search the skies for signals, but we are looking for voices that went silent millennia ago, mere decades after they began broadcasting. We are listening to a cemetery. This is the great filter. Somewhere between single-celled organisms and galaxy-spanning civilizations, there is a barrier that almost no one crosses. Either the emergence of complex life is incredibly rare, or intelligence is rare, or technological civilization is rare, or something kills nearly every species that reaches our current level of development. Given that we exist, given that we have cleared the hurdles of evolution and intelligence and civilization, the most probable location for the Great Filter is immediately ahead of us, in our near future. In the next few decades or centuries, we stand where countless civilizations may have stood before, at the precipice where our tools have become powerful enough to end us. The silence we hear when we point our telescopes at the stars may be our own future. A civilization that arose, briefly flickered into radio visibility, and then went dark. Another entry in the galaxy's ledger of failed experiments. And billions of years from now, perhaps another species will evolve on another world, will develop their own telescopes and radio receivers, and will wonder why the universe seems so empty. They will not hear our signals because we will have been silent for eons. Another casualty of technological adolescence, another species that gained the power of gods before developing the wisdom to wield it. In the heart of Beijing, in the year 28, a Chinese science fiction author named Louis Cixin published a novel that would fundamentally change how humanity views the cosmos. The book, called The Dark Forest, presented a solution to Fermi's paradox so chilling, so mathematically elegant in its horror, that scientists around the world found themselves unable to dismiss it. Unlike earlier explanations that relied on hope or optimism about alien civilizations, Liu's theory explained the Great Silence not as an absence of life, but as evidence of something far more terrifying. A universe saturated with intelligent species, all hiding in absolute silence, paralyzed by fear. The Dark Forest theory begins with 3 simple axioms, each one innocent enough on its own, but devastating when combined. The first axiom: survival is the primary need of all civilizations. Every species that has clawed its way to intelligence has done so through an evolutionary gauntlet that rewards one thing above all else: staying alive. This drive, burned into the deepest layers of consciousness, doesn't disappear when a species reaches the stars. It intensifies. The second axiom: civilizations continuously grow and expand, but the matter and energy in the universe remain constant. Resources are finite. There is only so much material to build with, only so much energy to harvest. Every civilization eventually reaches the boundaries of what their local space can provide, and they must look outward, toward the territories of others. The third and final axiom: chains of suspicion exist between civilizations, and technological explosions can occur at any time. This is where the theory transforms from economics into nightmare. Imagine you detect another civilization. They are light years away, separated by gulfs of space so vast that communication takes decades or centuries. You send a message: "We come in peace. Let us be friends." You wait 50 years for a response. When it comes, how do you know they're telling the truth? How do you know their message of friendship isn't simply buying them time while they prepare weapons? You can't. You have no shared history, no common reference points, no way to verify intentions. They are fundamentally alien. Their thought processes, their values, their definition of friendship or threat might be incomprehensible to you. This is the first layer of suspicion, but it goes deeper. Even if you believe they are peaceful now, how do you know they'll remain peaceful? You've detected them at a specific moment in their development, but technology doesn't stand still. The civilization that seems primitive and harmless today might undergo what Lui calls a technological explosion within a century, leaping from simple radio transmissions to weapons capable of destroying stars. Human history provides the template. We went from the first powered flight to atomic weapons in 42 years. From primitive computers to artificial intelligence in a single human lifetime. Extrapolate that curve across alien species with different evolutionary pressures, different environments, different ways of thinking, and the rate of change becomes impossible to predict. The friendly neighbors you greet today could become existential threats tomorrow, and you'll never see it coming until their weapons arrive at your doorstep. Now layer on one more level of complexity. You know you're suspicious of them. But you also know they must be suspicious of you. They're thinking exactly what you're thinking, running through the same calculations, weighing the same impossible odds. You suspect them, they suspect you, and each of you knows the other is suspicious. This is the chain of suspicion, and once it begins, there's no breaking it. No communication, no matter how sincere, can overcome the fundamental uncertainty. You cannot prove peaceful intent across the void of space to a mind you cannot comprehend. Given these conditions, what is the safest strategy? Liu's answer is stark. Strike first. If you detect another civilization, you destroy them immediately, before they can locate you, before they can judge your intentions, before they can launch their own preemptive strike. You don't negotiate, you don't communicate, you don't wait. You eliminate the threat while you still can. This is the dark forest principle. The universe is a dark forest, and every civilization is a hunter moving through it in absolute silence. You step carefully, quietly, because everywhere in the forest are other hunters. If you make a sound, if you light a fire, if you reveal your position, the other hunters will see you, and they will kill you, not out of malice, but out of rational self-preservation. The implications cascade outward like ripples from a stone thrown into still water. Suddenly, SETI's decades of silence makes perfect sense. We've been listening for transmissions from advanced civilizations, assuming that advanced species would naturally want to communicate, to share knowledge, to join some sort of galactic community. But under dark forest logic, broadcasting your location is suicide. Any civilization that survived long enough to become advanced would have learned this lesson, possibly through watching other civilizations blink out of existence after revealing themselves. The galaxy might be absolutely crowded with intelligent species, thousands or millions of civilizations, all listening with instruments far beyond our current technology, monitoring every frequency for the slightest whisper of another voice, and all of them maintaining perfect radio silence, terrified that speaking might be the last thing they ever do. Some theorists have extended the dark forest concept to include what they call berserker probes, named after a concept from science fiction writer Fred Saberhagen. Imagine an ancient civilization, billions of years old, long since transcended or extinct, but paranoid enough about future competitors that before they disappeared, they manufactured a final solution. Self-replicating machines, each one programmed with simple instructions, spread through the galaxy, harvesting resources to build copies of yourself, and sterilize any planet showing signs of technological civilization. These probes would be fully automated, requiring no guidance, no ongoing maintenance, no living operators. They would be artifacts of a dead species' fear, still carrying out their murderous programming long after their creators turned to dust. Under this scenario, the galaxy might be patrolled by millions or billions of such machines, a distributed immune system that attacks any emergence of intelligence, like antibodies destroying an infection. The Berserker hypothesis explains several troubling aspects of our observations. It explains why we see no evidence of widespread colonization or megastructures. Any species that tried to build obviously would attract the attention of the probes. It explains why life seems to restart repeatedly on Earth, with mass extinctions punctuating the fossil record at regular intervals. Perhaps some of these weren't natural disasters, but targeted cullings whenever life on Earth approached technological sophistication. It explains why, if the universe is billions of years old, and life should have emerged countless times, we seem to be alone. We're not alone. We're simply living in the brief window between when a civilization becomes detectable and when the executioners arrive. Now, with this framework in mind, consider what humanity has done. In 1974, scientists at the Arecibo Observatory in Puerto Rico transmitted a radio message toward the globular cluster Messier 13. The message contained information about human DNA, our solar system structure, and even an image of a human figure. We packaged our location, our biology, and our level of technological advancement into a neat bundle and fired it into space, where it will travel forever, an eternal beacon saying we are here. This is what we are. Come find us. The message will reach its destination in approximately 25,000 years, and if anyone is home, their reply will take another 25,000 years to return. Our descendants, 50,000 years from now, might receive an answer. or they might receive something else entirely. Then there are the Voyager probes, launched in 1977, each carrying a golden record. These records, prepared by a committee led by Carl Sagan, contain sounds and images selected to portray the diversity of life and culture on Earth. They include greetings in 55 languages, music from different cultures and eras, and even encoded images showing human anatomy, our planet's location, and mathematical and physical formulas. The probes are now beyond the heliopause, in interstellar space, traveling forever as ambassadors of humanity. They're also permanent roadmaps leading directly to Earth, drifting artifacts that any sufficiently advanced civilization could intercept and decode. We included a pulsar map showing Earth's precise location relative to 14 pulsars, essentially cosmic GPS coordinates. If the dark forest theory is correct, we didn't send ambassadors. We sent invitations to our own execution. More recently, projects like METI, Messaging to Extraterrestrial Intelligence, have deliberately transmitted powerful radio signals toward nearby star systems. In 2008, a message was beamed toward Gliese 581c, a potentially habitable exoplanet. In 2017, another message was sent to GJ 273. These weren't accidental leakage from our television broadcasts, weak signals that dissipate quickly. These were focused, powerful transmissions designed specifically to be detected across interstellar distances. We are actively trying to get noticed. Not everyone celebrated these efforts. Stephen Hawking, one of the most brilliant physicists of our time, repeatedly warned against attempts to contact alien civilizations. In a documentary series aired in 2010, he stated that while alien life almost certainly exists, attempting to make contact could be catastrophic for humanity. He pointed out that we only have to look at ourselves to see how intelligent life might develop into something we wouldn't want to meet. Hawking drew parallels to what happened when Christopher Columbus arrived in the Americas, noting that the encounter didn't turn out well for the Native Americans. If aliens visit us, he warned, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. Other scientists share these concerns. Dan Wertheimer, a key figure in SETI research, has argued that broadcasting our presence is too dangerous given our complete ignorance of what might be out there. The astronomer and science fiction author David Brin has been particularly vocal, describing active METI projects as potentially catastrophic and scientifically unjustifiable. He points out that these decisions are being made by small groups without any democratic process, without consultation with the broader scientific community or the public, despite potentially affecting the entire future of human civilization. They are betting the survival of our species on the hope that whoever receives our messages will be friendly. But under dark forest logic, friendliness is irrelevant. A sufficiently advanced civilization faced with evidence of another species doesn't need to be cruel or aggressive. They simply need to be cautious. Why take the risk? Why assume that these newcomers won't eventually pose a threat? The safest course is elimination, performed quickly, efficiently, and from a distance. Perhaps they'll feel regret. Perhaps they'll memorialize us. Perhaps they'll study our final transmissions with anthropological interest. But they'll still destroy us, because the alternative, accepting the risk of an unknown species with unknowable intentions, is simply too dangerous in a universe of finite resources and infinite uncertainty. The most disturbing possibility is that we're living on borrowed time. Our radio transmissions have been leaking into space since the early 20th century, spreading outward at the speed of light in an ever-expanding sphere. That sphere is now over 100 light-years in radius, encompassing thousands of star systems. If anyone was listening, they've heard us. If dark forest theory is correct, and if there's anyone within that sphere, they now face a decision. And if they've decided we're a threat, something may already be coming. A relativistic weapon, perhaps, a projectile accelerated to a significant fraction of light speed, containing enough kinetic energy to shatter our planet. Or a self-replicating swarm of nanomachines, spreading like a virus. Or something we can't even imagine, a weapon based on physics we haven't discovered yet. It would be silent, invisible, and we would have no warning until the moment it arrived. By the time you read these words, the executioners might have already left their home world, traveling toward us through the vast darkness between stars. Our fate might have been sealed decades ago, and we're simply waiting for the consequences to catch up with us. We shouted into the dark forest, and somewhere, something heard us. Now there's nothing to do but wait, and listen, and hope that the silence continues. Because the moment the silence breaks, the moment we detect that response we've been hoping for, we'll know that we made the most terrible mistake in human history. We'll know that the hunters have found us, and by then it will be far too late to hide. In 1973, a radio astronomer named John Ball sat in his office at NID and proposed something that would shake the foundations of how we understand our place in the cosmos. Ball had spent years listening to the silence of space, searching for signals that never came. But unlike his colleagues who saw this silence as evidence of our solitude, Ball suggested something far more unsettling. He called it the zoo hypothesis. We are not alone, he argued. We have never been alone. Advanced civilizations know exactly where we are. They have always known. And they are watching us right now, observing every move we make with the detached curiosity of scientists studying animals in an enclosure. Think about the last time you visited a zoo. You stood outside the glass, watching the creatures inside go about their lives, completely unaware of your presence. They cannot comprehend the barriers that contain them. They do not understand that their environment has been carefully constructed, their food supply managed, their breeding monitored. They believe they are free. They believe their world is real and complete. Now ask yourself this question, and really sit with the discomfort it brings. What if we are those animals? Ball's theory emerged from a simple but profound observation. If intelligent life had emerged anywhere in our galaxy before us, even just a few million years earlier, they would have had more than enough time to colonize the entire Milky Way. Our galaxy is roughly 100,000 light-years across. A civilization expanding at just 1% of light speed could traverse that distance in 10 million years. The galaxy itself is over 13 billion years old. The numbers are staggering. There has been more than enough time for dozens, perhaps hundreds of advanced civilizations to arise and spread across every star system. So, where are they? The traditional answer to this question, known as the Fermi Paradox, usually assumes either we are alone or they simply do not exist. But Ball proposed a third option that feels far more sinister the longer you consider it. They are here. They have always been here. But they have chosen not to reveal themselves. They maintain what he called a zoo, or a wilderness preserve, allowing us to develop naturally without interference, observing us from a distance we cannot perceive. Science fiction fans might recognize this concept from Star Trek's Prime Directive, the ethical rule preventing advanced civilizations from interfering with less developed species. It sounds noble on the surface, a cosmic code of conduct born from respect for natural development. But Ball's hypothesis does not necessarily imply such benevolent motivations. What if the reasons for our isolation are far darker? What if we are not being protected out of respect but preserved for purposes we cannot fathom? Consider what humans do with nature preserves. Yes, we protect endangered species, but we also study them. We track their movements. We tag them. We take samples. We control their populations when we deem it necessary. Sometimes we preserve them because they are beautiful or interesting. Sometimes we preserve them because they might be useful later. And sometimes, if we are honest, we preserve them simply because we can, because the act of preservation makes us feel powerful and benevolent. What if Earth is not a nature preserve at all, but a laboratory? What if humanity is an experiment, our entire history carefully curated and controlled by entities with agendas we cannot comprehend? This possibility becomes more disturbing when you look at certain anomalies in our development that scientists struggle to explain. Take the Cambrian explosion, that mysterious period roughly 540 million years ago, when complex life suddenly erupted across Earth in an astonishing burst of diversity. For billions of years, life remained simple, microscopic, unremarkable. Then, in geological terms, almost overnight, an explosion of complex organisms appeared. The fossil record shows species emerging fully formed with sophisticated body plans, eyes, predator-prey relationships, and ecological niches. It happened so fast that Charles Darwin himself called it a problem for his theory of evolution. Some researchers have proposed panspermia, the idea that life or its building blocks came from space. But what if it was not random? What if it was deliberate? What if someone or something seeded Earth with the genetic material necessary to create complex life, then sat back to watch what would happen? The anthropic principle adds another layer of strangeness to our existence. The fundamental constants of the universe, things like the strength of gravity, the mass of the electron, the cosmological constant, are fine-tuned to an almost impossible degree. Change any of these values by even a tiny fraction, and the universe could not support life as we know it. Stars would not form. Atoms would not hold together. Everything would fly apart or collapse. The odds of this fine-tuning happening by chance are so astronomically small that many physicists find it deeply troubling. Some propose a multiverse where every possible configuration exists, and we simply happen to be in one that works. But there is another explanation, one that sends chills down your spine once you consider it seriously. What if the universe was designed this way? What if the fine-tuning is not coincidental, but intentional? What if we are living inside a constructed reality, and the constants were set specifically to produce creatures like us? Then, there is the sudden and accelerating pace of human technological development. For most of human history, progress was glacially slow. We spent hundreds of thousands of years as hunter-gatherers. Agriculture appeared only about 10,000 years ago. Writing came 5,000 years ago. But then something changed. In the last few centuries, technological progress has exploded at an exponential rate. In just the last 70 years, we have gone from the first computers filling entire rooms to supercomputers in everyone's pocket. We have split the atom, mapped the human genome, and sent machines to explore other planets. This acceleration is unprecedented in the history of life on Earth. Is this natural? Or is something guiding us, pushing us toward a specific developmental milestone? Some researchers have pointed to moments in history that seem almost too fortunate to be coincidental. The simultaneous discovery of calculus by Newton and Leibniz, the near-simultaneous development of evolution theory by Darwin and Wallace, the way certain technologies seem to emerge in multiple places at once, as if ideas themselves are being seeded into human consciousness from an external source. What if inspiration is not internal but transmitted? What if the greatest minds in human history were not geniuses but receivers, picking up signals broadcast into their minds by watchers who want us to reach a certain level of development? This brings us to perhaps the most terrifying implication of the zoo hypothesis: cosmic quarantine. If advanced civilizations are indeed watching us, they must have established some kind of boundary, some barrier that keeps them hidden and us contained. Ball himself suggested that Earth might be surrounded by an enforced perimeter, a kind of fence invisible to us, but impenetrable nonetheless. Think about what this means. Every time we send a probe into deep space, every signal we broadcast, every attempt we make to reach out into the cosmos might be carefully monitored and controlled. We think we are exploring freely, but perhaps we are only exploring the cage they have built for us. The quarantine concept becomes even more disturbing when you consider it might be bidirectional. Perhaps the fence is not just keeping them hidden from us, but keeping us contained for their protection, or for the protection of something else. What if Earth is not a preserve, but a prison? What if humanity is being contained because we are dangerous, unstable, or infected with something that must not spread? Ancient myths from cultures around the world speak of humanity being fallen, corrupted, expelled from paradise. What if these stories contain a kernel of truth? What if we are quarantined because we failed some cosmic test, and we are being held here until we prove ourselves worthy of contact, or until we destroy ourselves and solve the problem permanently? The most unsettling aspect of living in a zoo is that the animals never detect the surveillance. Modern zoos use hidden cameras, one-way glass, and concealed observation posts. The animals live their entire lives unaware that every behavior is documented, analyzed, and discussed by beings they cannot see. They think their world is complete, that their enclosure is the entire universe. Now scale this up to a cosmic level. If a civilization millions of years ahead of us wanted to observe Earth without detection, they would have technologies we cannot imagine. They could have sensors woven into the fabric of space itself. They could observe us from other dimensions. They could hide in plain sight using physics we have not discovered yet. Some researchers have suggested that UFO sightings might be evidence of surveillance drones, moments when the watchers become momentarily visible, either by accident or design. The patterns are suggestive. UFOs tend to appear near military installations, nuclear facilities, and technological centers. They observe but rarely interact. When they do interact, it often seems like a scientist briefly entering an enclosure to take measurements or collect samples. Witnesses report feeling paralyzed, experiencing missing time, having vague memories of examination. If Earth truly is a zoo, these incidents could be the equivalent of wildlife researchers tranquilizing an animal for tagging and study. The implications for human free will are perhaps the most philosophically disturbing aspect of this hypothesis. If we are being observed and potentially guided, how much of what we think of as free choice is actually authentic? When you decide to pursue a career, fall in love, create art, or explore a new idea, is that decision truly yours? Or are you following patterns that have been subtly encouraged, responding to influences you cannot detect? Psychology has already shown how easily human behavior can be manipulated through advertising, social pressure, and environmental design. Now imagine those techniques applied by intelligences millions of years more advanced, working on timescales of centuries or millennia. They could shape entire civilizations without anyone noticing. They could guide our development towards specific outcomes while leaving us convinced we chose our own path. Ball's zoo hypothesis also raises questions about the nature of reality itself. If we are being observed by higher intelligences, perhaps our entire existence is less real than we assume. Philosophers have long debated whether we might be living in a simulation, and the zoo hypothesis provides a motivation for such a simulation. Advanced civilizations might run countless simulations of developing species, watching how different variables play out. You might be one of billions of simulated humans living in a digital zoo, your entire reality, nothing more than a sophisticated computer program designed to generate data for researchers you will never meet. The silence from space takes on new meaning in this context. We have been listening for signals for decades with increasingly sophisticated equipment. We have heard nothing that resembles intelligent communication. The zoo hypothesis suggests this silence is maintained deliberately. They are out there, perhaps all around us, but they are using communication methods we cannot detect, or they are simply choosing not to respond to our calls. Imagine shouting into the darkness, not knowing that sophisticated listeners are hearing every word, but choosing not to answer because the experiment requires your isolation. The question we must face, the one that keeps astronomers awake at night and philosophers troubled, is this. If we are in a zoo, what happens when the experiment ends? What happens when we reach the development level they have been waiting for? Do they make contact? Do they welcome us into a galactic community? Or do they simply close the file, terminate the simulation, and move on to the next experiment? What if we are not the first Earth they have seeded and observed? What if they have run this experiment hundreds of times before, watching civilizations rise and fall, taking notes on what works and what does not? Perhaps the most terrifying possibility is that we will never know. The animals in the zoo never understand the glass that contains them. They never see the cameras watching them. They never comprehend that their entire world is an artificial construction maintained by beings beyond their understanding. They live and die believing their reality is complete and natural. If Ball's hypothesis is correct, we may be no different. We may spend the entirety of human existence being watched by entities we cannot perceive, following scripts we did not write, believing we are free while living in the most sophisticated enclosure ever constructed. And we will never ever know the truth. The radio telescopes stand in the desert like silent sentinels, their massive dishes tilted toward the heavens, listening. Always listening. For more than 60 years now, they have maintained their vigil, sweeping through frequencies, analyzing billions upon billions of signals, searching for that one unmistakable sign that we are not alone. And in all that time, across all those signals, they have found nothing. Nothing but the endless whisper of cosmic background radiation, the dying echo of the universe's birth, spreading through the void like static on an abandoned channel. This is where we return, after examining every proposed solution, to the Fermi Paradox, back to the overwhelming silence, back to the haunting absence that started this mystery in the first place. Because regardless of which explanation seems most plausible, regardless of how we theorize about filters and zoo hypotheses and hidden civilizations, we cannot escape one fundamental, undeniable fact. The silence is real. The emptiness is measurable. And with each passing year, with each negative result, that silence becomes more profound. Consider what we've accomplished in our search. The SETI Institute has analyzed transmissions from distant stars. The Allen Telescope Array scans the skies continuously. Breakthrough Listen, backed by $100 million in funding, uses some of the most powerful telescopes on Earth to examine thousands of nearby stars. They process data at extraordinary speeds, searching for patterns, for regularities, for anything that might suggest an artificial origin. And they find quasars and pulsars. They find the background hum of distant galaxies. They find the natural electromagnetic symphony of the cosmos. But they do not find them. They do not find anybody. New projects promise to deepen our search. The James Webb Space Telescope peers into the atmospheres of distant worlds, looking for biosignatures, for chemical imbalances that might suggest life. Future arrays will be even more sensitive, capable of detecting even fainter signals from even greater distances. But here is the uncomfortable truth that researchers quietly acknowledge in their darker moments. These tools may not provide answers. They may only deepen the mystery. They may only make the silence more deafening by proving that we can hear further than ever before. And still, we hear nothing. Think about what each potential solution to the Fermi Paradox actually means for humanity. If we are alone, truly alone in this vast cosmos, then we are living in a universe of unimaginable loneliness. Hundreds of billions of galaxies, each containing hundreds of billions of stars, and consciousness arose only here. Only once, only us. The weight of that isolation is almost unbearable to contemplate. If the great filter lies ahead of us, then we are the walking dead, a civilization approaching an invisible wall that no intelligent species has ever passed. Somewhere in our future, perhaps soon, perhaps in centuries, we will reach the point where all others failed. And we will join them in extinction, another failed experiment in the universe's long history. If we are being hunted, then we are prey that has already been noticed. Every signal we have sent into space, every radio wave and television broadcast leaking from our atmosphere, might be drawing predators closer. We might be living in our final moments of innocence, before something vast and incomprehensible turns its attention our way. If we are being observed, studied like specimens in a cosmic zoo, then our entire existence is a kind of cage. Free will might be an illusion. Our development might be managed, our future predetermined by forces we cannot perceive. We might be as powerless as bacteria in a petri dish, while vast intelligences watch our every move with detached curiosity. And if civilizations are simply too far apart, too spread out across space and time to ever make contact, then the universe is a graveyard of species that lived and died alone, calling out into darkness that swallowed their voices without echo. None of these solutions is comfortable. None of them allows us to sleep easily. Each one reveals something terrifying about our place in the cosmos, about our significance or lack thereof, about our future or lack thereof. Scientists continue their work with a dedication that borders on the obsessive. They refine their instruments. They develop new search strategies. They examine anomalies with rigorous skepticism, hoping that this time, this signal might be different. But in their quiet moments, some of them wonder if they are afraid of finding something, or afraid of never finding anything. Both possibilities carry their own horror. The silence suggests something is fundamentally wrong with our assumptions. Either intelligence is far rarer than we believed, or it destroys itself with remarkable consistency, or it hides with perfect success, or it exists in forms we cannot recognize. None of these options is reassuring. Perhaps the most merciful possibility is that we never learn the answer. Perhaps the Fermi Paradox should remain forever unsolved. A question that echoes through the generations without resolution. Because the truth, whatever it is, might be something that changes us irrevocably. Knowledge, after all, cannot be unknown. Some doors, once opened, cannot be closed again. So the telescopes continue their watch. The data streams in. The analysis continues. And the question Enrico Fermi asked all those decades ago in a casual lunchtime conversation remains unanswered, hanging in the air like a ghost that refuses to be laid to rest. Where is everybody? The universe offers no reply. And in that silence, in that vast and empty darkness, we are left with our theories and our fears, our hopes and our instruments, searching for an answer that may never come, or that may come in a form we cannot bear to accept. The mystery endures. The silence continues, and we listen still, not knowing if we should hope for a signal or hope that the silence lasts forever. That's where this journey ends for tonight. If you made it all the way here, subscribe and hit the bell for more long-form stories like this. Check out the videos on screen for more right now. Drop your own experiences in the comments below. Thanks for listening, and I'll see you in the next one.